This is CPM Precalculus Chapter 2, number 158. So we're trying to look for the area under the function f of x is equal to 3x cubed plus 1 on the interval from 1 to 3. And we want to approximate it using 10 left endpoint rectangles. Actually, we know how to do this. This is just going to be in area notation, area under our curve between 1 and 3, right? And we know how to do this in general. Okay, so in general, let me just write this up here. In general, we area under our curve f between a and b, right? We saw so many patterns that we can see using left endpoint. I'm going to say sub L here. Left endpoint rectangles. We start with some variable k, any variable we want. We start with equal to 0. We go up to n minus 1, where n is the number of rectangles. We multiply by the base of every rectangle, which we'll call delta x, and the height of every rectangle, which we'll call f of a plus delta x times our variable k. Okay, and we know n, again, is the number of rectangles, and delta x is the width of each rectangle, which is b minus a over n. All right, so let's go ahead and do part A. This right here, right, allows us to skip all of the work that we've been doing to go ahead and show how we see this pattern, right? So the summation notation we know is using sigma. So the area using 10 left endpoint rectangles, again, is just equal to sigma, right? We're going to start at k0 to n minus 1, so that's 9, because 10 here is our n. Delta x we know is b minus a over n. So let me go ahead and calculate delta x is b minus a, 3 minus 1 over n, which is 10, which is 2 over 10, or 0.2, right? So it's going to be, again, delta x, 0.2, times our function at a. So what's a? A is where we're starting, 1, plus delta x, again, is 0.2, times k. Okay, so this is the summation notation. Plugging in our function, though, we have sigma from k equals 0 to 9, 0.2, and f of this, we know, well, our function is f of x is x cubed, 3x cubed plus 1. So here we're going to have f of 1 plus 0.2k, right? So it's going to be 3 times 1 plus 0.2k cubed plus 1. And this is the representation. We are done with part A, right? We know where it starts and where it stops, the width of every rectangle, and this is the height of every rectangle, again using left endpoint rectangles. All right. Part B says to make a small change to find the summation notation using right endpoint rectangles. We know that the area using right endpoint rectangles is the same as the left, but we add 1 to both of these indices. So this now becomes k, instead of 0, 0 plus 1 is 1. Instead of 9 as the stop indice, 9 plus 1 is 10. And the rest is exactly the same. 0.2 is the width. 3 times 1 plus 0.2k cubed plus 1 is the height of every rectangle. And again, this is for right endpoint rectangles. Okay, so once you get part A, part B is easy, and part C we're going to see is also easy. Here we're asked to make a small change to part A again, so that the sum we find uses midpoint rectangles. All right. So again, using the midpoint, the big thing to remember is, here's a rectangle. Right, let's go ahead and draw it. We're looking at 3 places in the rectangle. This is the left, this is the midpoint, and this is the right. So I'm going to call it left, midpoint, right. Okay, so to get to the left, we just start at k is 0 and f of whatever a is, right? because our first rectangle starts at A and we go from A to B, right? Our region is A to B, A to B, and we want to calculate all this area, right? If we start at the right endpoint, we're going to go ahead and get where the function hits the rectangle on the right side to get the height, and that's why we're going to be adding 1 here to go ahead and get the right side. Okay, so again, the small change, all we need to do is our function here, instead of starting at, let's go all the way up here, instead of starting at A here, for midpoint, we're going to start at A plus half of delta x. Okay, this is the big change. Okay, we're going to add half of delta x to our A, and then it's going to be exactly the same otherwise of A sub L, right? So A using midpoint, the area using midpoints, again, is going to be the same as the area using the left endpoint, right? So it's going to be the summation, sigma, starting at 0 still, ending at 9, same thing. Let's look here, or we could look here. Let's start here. 0.2 times f of, and instead of a, we have a, I'm going to write a plus delta x times 1/2, right? Again, I'm going to remind it, 1/2 of delta x. So delta x we know is 0.2, so half of 0.2 is 0.1. Okay, so this is the big difference. We're adding in half of delta x. Okay? So then we still have the plus 0.2k. Alright, and what that equals then is summation starting at k is 0 to 9, 0.2. Our function, remember, we could combine like terms, so let's just do that first before we get our final answer. It's 0.2 times f of 1.1 plus 0.2k, right? We plug into our function. Remember, our function is just y is equal to 3x cubed plus 1, right? That was given to us. F of x is 3x cubed plus 1. So when we plug this into our function, we get 3 times 1.1 plus 0.2k cubed plus 1, right? And we're multiplying that as our height for every rectangle. Okay? So again, the small change is to add in, this is now a plus 1/2 delta x. Okay? Because this is going to make us start at, instead of the left hand, it's going to make us move over delta x, half of delta x, to get to our midpoint. Okay, so this ends for us CPM Precalculus Chapter 2, number 158.